So we used to have, gosh, what was his name? Sajan? Saj? Is that how you say his name? Sajan. And he tore his Achilles tendon. Yes. Yes. So he now is only doing half days in the afternoon. So he is no longer in this class, and he's going to have Miss Bieshki, which I was like, ooh, because he always participated a lot, and I was like, ooh. So anyway, so he's back to school, but it's only going to be half days in the afternoon. So if you see him, say hello, all that kind of good stuff. All right. You use the information above, set up a two-way table. Okay, so we have, of the vaccination people, which there was a total of 238 people who got vaccinated, 262 got the placebos. In both groups, people still got malaria. Okay, so those that were vaccinated, there were 22 vaccinated kids who still got malaria, and in the placebo, 28 out of 262 kids still got malaria. Okay, how many total kids got malaria? Looking at this two-way table, how would we find that answer? How many total people, total kids got malaria? Add what? Yeah, add cell 1 and cell 2 together. 22 plus 28 gives a total of 50. Yeah, so 50 kids all together got malaria. So this is how a two-way table works. If you have for that second row and you are given cell 1 and 2 and the last column is total, you just add them together. Now, take a look at the vaccinated column. Vaccinated column, you have in cell 122, we don't have cell 4, but I do have cell 7. How could I find the number for cell 4? If cell 7 is total, how could I find the number I need for cell 4? Subtract. Subtract what? Yeah, subtract 7, cell 7, which is 238. Subtract the 22 that we do have from cell 1, and you get 216. Okay, so everybody see how that works? If you're going down the column, you add the first cell in that column to the second to get the total in the third. So you would do the same thing for placebos. What is my amount? Everybody take out your calculators. Hopefully you got one there. What is your amount that we need in cell 5? Those are placebo people who did not get. What is it? 234. So you could take 262 minus 28 and get 234. So looking at the only cell which is left, cell 6, you could add cell 4 and 5 and get 6. Or what else could you do? Subtract. Which one seems to be easier to do? Would it be what? Yes. If this wasn't, yes, I don't have 9 here. That's why. Yes, 9 and 3. That would be a little easier. Yes, I know. Because 500 minus 50 is 450. And just for giggles and grins, ha ha ha, check, is 216 plus 234. Does that give you 450? Yes. They should all add up to be the same. If they don't add up, then something's wrong and you need to recheck part of your table. Okay, so then it says, use your two-way table to determine whether the vaccine is effective or not. Use your two-way table to determine whether the vaccine is effective or not. What did we use earlier. What did we use earlier? Didn't we use something earlier where we went and talked about percentages? So we might need to look at some percentages for some of these answers. How can we tell whether the vaccine is effective or not? What would you suggest that we find?
We know it's effective when they don't have malaria?
Yeah, we don't want them to have malaria. So, right? I don't want to get malaria. Do you? Do you want malaria? No, we do not want malaria.
Okay, so if it was 50 and 450, would they still give it to kids?
Give what?
Like the shot, the vaccine? Or would it need to be 100% effective?
I don't think anything's 100% effective.
So there'll still be people who get malaria?
Oh, yeah. I mean, that's what this says. 22 people who got the vaccine got malaria. Okay? So, what kind of number should we look at? What about all those that are vaccinated? What would be in my denominator for all those that were vaccinated? What's my total for all those that were vaccinated? 238. So this is all of those that were vaccinated. Okay. And what do you want to put on top of it? The ones that got malaria or the ones that didn't? Probably maybe the ones that got it, right? So what number would that be? 22. So on your handy dandy calculator, what is 22 out of 238? What is it as a decimal? Come on, people. Aiden, raise your head. Come on. What is it? I was going to say 0.9. That's really high. 0.09. What's the next number? Is there 24? So what is this as a percent? 2 places to the right. This is 9.2% of all those who got vaccinated still got malaria. Okay? What should we compare that number to? Those who got the what? The placebo and got malaria. So let's check that out. How many total kids got the placebo? 262. This is the placebo total. And how many of those kids still got malaria? 28. So what is 28 divided by 262? Do we need some traveling music? 28 divided by 262. Somebody give me a number. Come on. What is it? 0.1. 28 divided by 262. Guys, everybody should be doing this. We don't have like one calculator for the whole class. What was that? One more time. Just like 3 places out. 106. Okay. So what is that as a percent? 10.6, right? So this is 10.6%, and this is 9.2%. What do you think about those percentages? Is there a big difference between the placebo, those that got the placebo and got malaria, and those that got the vaccination? So would you say this vaccine is effective or not? It's more effective, yes, but would you say it's effective? I would probably tend to say no. Okay? The percent, I would say no, but you're entitled to your own opinion. No, because the percent of kids is too close for vaccinated versus placebo. In other words, there is less than a 1% difference. Well, just over 1%, I guess. There's just over a 1% difference, which is not a lot. Okay? A 1% difference in the number of kids who got malaria with the vaccine, then got the malaria with the placebo. Do you believe the vaccine is effective? So maybe you have some personal opinions about that. Okay? Why might some other people say it is effective? Why might some people say that, though? Let's be the devil's advocate. Because remember, you just have to justify your reasoning. And some people might say, I would take the vaccine. Why might someone say, yes, I would take the vaccine? Because it doesn't have to do with what they think, but just looking at the facts, what would they say? That's right. They would say, hey, a smaller percentage got malaria. And maybe they're a person that believes in vaccines too. Not everybody believes in vaccines, and that's fine. But some might say, some might use vaccines in general, and even a small increase in not getting malaria is better. That's what they would say. Okay? So again, when it comes to statistics, you can kind of take things either way. You just have to be able to back it up. All right? Any questions about this? Does this make sense? Where someone might say, yes, it is not effective, or yes, it is effective. All right. Let me know when you're done with this slide. So some might use vaccines in general. There are 4 vaccines, and even a small increase in not getting malaria is going to be better than getting it. Okay? All right. Okay, so that's what we wanted to finish from